Okay, so one unit of measurement that we saw is degrees. Another unit of measurement I'm going to present now is a radian. But what exactly is a radian? Well, to define a radian, we need the concept of a central angle. And it says here what a central angle is. It's pretty well, I shouldn't say it's self-explanatory, but let me draw a picture to help illustrate it. Basically, an angle is a central angle if its vertex is the center of a circle and the angle is positive, meaning it's formed by rotating counterclockwise. So this would be a central angle. Okay. Also, we say here that the rays subtend an arc on the circle. That just means we have this picture here. We have this picture. So you can imagine then taking this picture and doing this if we were to just focus on that. So here is the arc here. And now remember, the vertex is the center of the circle. So the circle has radius. As you can see down here, I'm calling it R. So let me label that. So this is R, okay? Now, what I'm going to do is let S be the length of this arc that we formed, okay? So this here, I'm calling it S, the length of it. So S is the length of this arc. Okay? Again, it's the length of the arc that's between the angle's initial and terminal side. Again, the angle is positive, so it's a counterclockwise rotation. Then we say the angle is 1 radian if S and R are the same. So, by definition, that's just what 1 radian is. Let me see if I could draw that one more time. Okay, so this is R. This is R. Again, R is the radius of the circle, as I say right here. This is 1 radian. Okay? When this arc length, okay, let me illustrate that here to make it easier to see, is also R units long. That's just what 1 radian is by definition. Okay, that's just what it is by definition. So it's 1 radian again if S equals R. If this arc is also R units long, R being the radius of the circle. Okay, now from the definition of what a radian is, we get a very nice theorem here. Let me draw that picture again from before. So again, you can imagine this is a central angle. Okay, this arc here is part of the circle. R is the radius of that circle. And as before, the length of this little arc here, that's what we call, that is S. S is the length of that. And let's suppose this angle, this is a central angle now, okay? So let's say this is theta radians. Then it turns out, it really just follows from the definition of what a radian is. It turns out that S is equal to R times theta. S is equal to R times theta. And let me just say this, that for this theorem, theta has to be in radians. This theorem is not going to make sense if theta is in degrees. Let me just do a quick example of this. Suppose R was 2 meters. So the radius of the circle is 2 meters. What we want is the length of the arc subtended by the central angle. Again, that's just this arc here between the initial and terminal side. We want the length of that, which is S, when theta is half a radian. So in other words, we're just going to use the formula here. That's all it boils down to. So we're finding S if theta is 0.5 radians and r is equal to 2 meters. And really, I wrote it up here also, but S and R have to have the same units of length. Okay, so let's just use the formula. We get S is R times theta. So in this case, we're going to have 2 times 0.5, which in this case turns out to be 1 meter. S and R, again, are going to have the same units of length. So S and R, in this case, are meters. Theta is radians. Okay, good. All right, so we have these 2 units of measurements for an angle, degrees and radians. Can you go from one to the other? Well, it turns out the answer is yes, you can. And I'm going to show that shortly.